Welcome to Solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, what we want to do is kind of walk through what is classified as a stoichiometry, where we're finding moles and grams based off of a balanced chemical reaction. And so we're told that sulfuric acid actually dissolves aluminum metal um, through this chemical reaction where we have a solid aluminum plus some sulfuric acid will produce aluminum sulfate um, plus hydrogen gas. Couple things, make sure when we're doing this, even though we have coefficients, make sure it is a balanced chemical equation. So we're going to just step through that process. So we have two aluminums on the left, and we look two aluminums on the right. We have 3 times 2, we have 6 hydrogens right here, and we have 6 hydrogens. And then we have 3 of your sulfates, and we have 3 of our sulfates. So it's balanced. And what we want to do is the first thing, we're going to do a couple things. The first thing is we want to dissolve a 15.2 gram aluminum block. And we want to know basically how much sulfuric acid do we need? Okay, so if I want to completely dissolve this 15.2 gram block, how much sulfuric acid am I going to need for this chemical reaction? Okay, so based off that, I like to use what is called the T-bar method, where I kind of set up successive T's. So I always, here is my T to start with. I always put what I'm given in that top left corner. So I have 15.2 grams of aluminum. Okay, so I know my coefficients, and we're working with aluminum to sulfuric acid. These coefficients give me the mole to mole ratio. For every 2 moles of aluminum, I require 3 moles of sulfuric acid. Okay, so in order for me to use this ratio, I've got to have moles of aluminum. So I've got to use his gram atomic mass, right? So I have to go to the periodic table, and I know that aluminum is for 1 mole of aluminum, it has 26.982 grams of aluminum, right? That's off the periodic table. And so I always carry my units to help me out. So my grams of aluminum cancel out, and I'm left with a mole of aluminum, which is what I want, right? Because now I want to be able to use that ratio 2 to 3. And I know that I need the 3 on the top. So this is 3 moles of sulfuric acid for 2 moles of aluminum. And so my moles of aluminum cancel out, and I'm left with moles of sulfuric acid. Okay, but we can't go to the chemical store and ask for moles. We have to go to the chemical store and ask for grams. So now, once again, I have to find the gram molecular mass of sulfuric acid. So I have to go to the periodic table for hydrogen, which I have 2 of them, 1.008. Sulfur is 32.066. And then oxygen, I have 4 times the 15.999. Depending on what periodic table you have, it might say 16 on that. So I'm going to then, once I do the multiplication, I'm going to add all of those together, and I should get 53.964 grams per mole. Okay, so here in my next little T section, I want to end up with grams, so I know this is 53.964 grams of sulfuric acid for every 1 mole of sulfuric acid. So those units cancel out. And the only units I haven't canceled out is the grams of sulfuric acid, which is the units that I do want. So remember, I need to multiply everything together that is in the numerator, right? So I have to do 15.2 times 3 times that 53.964, and I should get 4472.3368. divided by, and now I have to multiply everything that's in the denominator. So 26.982 times a 2 times a 1, and I should get, that's not 53.96. This should be, I think I looked over at the wrong thing. That should be 98.078. So up here, I think that's my final answer over here. This should be 98.078 grams. Okay, and that should give me 44, and in the denominator should be the 26.982 times the 2. That is the 53.964, which gives me 82.9 grams of sulfuric acid. So if I want to dissolve this 15.2 grams of aluminum block, I need to start with 82.9 grams of sulfuric acid. Okay, and then the next thing we want to do is we want to determine how much hydrogen gas is produced when I dissolve this 15.2 gram aluminum block. So the kind of the same scenario now. So now I'm going here back to my original equation, and I don't want the 2 to 3 ratio now. I want the 2, well, it's still 2 to 3 because I have it, okay? But once again, I'm going to use that T-bar, and I'm going to start with 15.2 grams of aluminum. And I have to convert using its gram atomic mass. So 1 mole of aluminum gives me 26.982 grams of aluminum. So those units cancel out. I produce 3 moles of hydrogen gas for every 2 moles of aluminum that I start with. And now I just need to find the gram atomic mass of hydrogen gas. So I would do 2 times 1.008, which gives me 2.016 grams of hydrogen gas for every 1 mole of hydrogen gas. So those units cancel out, and I'm left with grams of hydrogen gas, which is what I want. Multiply straight across, and I should get 91.9296. And then divide that by 26.982 times the 2, which is the 53.964. So this gives me 1.07 grams of hydrogen gas. So I hope this helped you understand how to go through the